of going through this, the basics of this particular physics classroom assignment. So you're going to do free fall. You got to do all three levels. So the first level is going to ask you some questions about what happens to velocity or acceleration. So remember that the acceleration from gravity never, ever, ever changes, ever. The acceleration from a planet's gravity will never change. And the acceleration is always going to be in the same direction, down. Now, if you're moving up, that means you'll be slowing down. If you're moving downward in a free fall, that means you'll be speeding up. The direction of velocity depends on the direction in which it's traveling. If you're going upward, then your direction of velocity is upward. If you're free falling downward, then the direction of your velocity is downward. So a tennis ball is hit straight upward and it goes free fall. As it rises, what changes would be observed as it rises? Now you have to read the whole thing. The last part, the last sentence, what changes would be observed in velocity and acceleration as it rises towards its highest point. So the velocity is decreasing as it's moving up. The acceleration never changes. All right, it's a dot diagram. So which of these dot diagrams best describe the motion of a free-falling object that is dropped from rest? So if you drop something free-falling, it's going to increase its speed. Its speed will be changing. So which of these shows something that's increasing its speed? Is it going to be A, B, or C? Well, B, the distance between the dots is the same for each second. So it's not going to be B, that's constant. So if you drop something, the distance that it's traveling between seconds is going to keep increasing. And then you got some other questions to answer about that one. All right, so the acceleration is always downward. Velocity, well, which way is it moving? I think that's upward. I didn't read that all the way, but yeah, you got to read the whole thing. All right, so back to the main menu. All right, so now remember we're using 10 meters per second squared. We're not using 9.8. So if the ball leaves your hand at A, it's going to keep slowing down until it gets to E, where the velocity is 0. And then it'll start falling back to Earth. So it goes up and down, up and down. And the distance between the dots or the letters is a second. So a ball is projected upward with an initial speed of approximately 40. So it leaves your hand at 40. It leaves position A at 40. At what time will the ball be moving downward with 30? So at B it would be 30. At C it would be 20. At D it would be 10. At E it would be 0. And then F is 10, G is 20, H is 30. So you tap there. And they may have we don't have an answer choice, but in this case they don't. So hopefully that's right. Same thing here. So you're just going to answer several of these questions. So we went outside and we threw, I can't remember if you were here or not, we went outside, threw tennis balls up and sort of counted the time. All right, the hardest level, this one here, so you have to read the entire question. The speedometer at the top right is going to be how you determine your starting velocity. Now, it doesn't give you the starting velocity. You have to read. So a ball is equipped with a speedometer and launched straight upwards. Speedometer reading 4 seconds after launch is shown at the right. The best thing for you to do for these questions is to go ahead and just sketch that at 0. I would just have this out in front of you. So if you start at 100, then it would be 90 after a second, and then 80, and then 70, 60, 50. I'm going to have to redo this. 20, 10, 0, and then it's 10, 20, 30, 40, 50, 60, 70, 80, 90, downward. So, you have to read. The speedometer reading 4 seconds after launch is shown at the right. So that is 4 seconds after launch, and you have to check, is the ball moving upward or downward? So the ball is moving downward at 10, and it's 4 seconds after launch. So if the ball is moving downward at 10, if the ball is down right there, and it's 4 seconds after launch, that's 1 second, 2, 3, 4. So the initial velocity is 30. So you've got to be able to figure that out. So the initial velocity is 30. And reading the rest of the situation, at what approximate times would the ball be moving upward? And display the following speedometer reading. So is the ball moving up or down? So upward at 20, if it started out at 30, it would take 1 second for it to get to 20, and then it's going to go to 10 and 0, and then start falling down. Now, upward at 30, I think it left your hand at 30, and that was decided, yeah. So upward at 30. Now, occasionally, they are going to give you a question, and they're not going to tell you that in this last part, for these last two speedometers at the bottom that you use to answer the question, they are not going to tell you if the ball is moving upward or downward. So that means that it could actually have two answers, because you could actually mean 30 up and 30 down. In that case, you just keep tapping through the answer choices. One of the answer choices, they'll tell you, not this one. So that means you have to choose the other answer choice, so to speak. And then they also might give you a question that doesn't have an answer. So if the ball leaves your hand at 30, it would come back to your hand at 30, which means that it could never be 40 in the downward direction. So you got to watch out for that. And if you got any issues with that, just... All right, that is it.